Cool. All right. Getting going. I really need to learn how to flip this. People are definitely the most engaged right at the beginning. I need to have hands-on coding time first and then do some talking later, I think. All right. How's everyone doing today? Good? Yeah? It's weird. I feel very, it makes me feel at home from Wyoming that I have to wear my coat when I go into work in the morning. And then by the afternoon, it's like, oh my gosh, why did I ever need a coat today? That's not very North Carolina, but I'll take it. Nice, cool evenings, warm days. Dang it. You have to be very careful, I think, today, not to jostle this. All right. Hopefully that'll, oh, actually, I think the projector turned off this time. Well, this may be interesting. We may, interesting. It might have, sure, I don't know if it turned itself off or if it broke. Sounds like it's still on, doesn't it? I think the bulb finally just blew. Alrighty then. Let's see. Let's see if I can come up with a backup plan. What? I mean, I can. I don't know if it'll support everyone being online or not. I'm wondering if we could do something like that.
Screen share on Slack.
What?
Screen share on Slack.
Screen share on Slack. Is there probably something? Let's see. For those of you remote, by the way, we're slow because the projector in the room went out, and so we don't have a screen right now. You guys are seeing more than everyone here. So if there's room or if there's a TV anywhere that we can hook into, we're sort of going to look around, see if there's anything. If not, we'll probably just try and share screens. I've done this before. I had a conference where the power went out while I was giving a presentation and everyone just huddled around my laptop. It's all good. In the meantime, I'm definitely a little behind on getting out new assignments. I got some stuff out after last Saturday or last weekend, but I didn't get anything out after Tuesday yet. Anybody have any problems with the stuff that is out there right now? Yeah?
Okay, so we had to the pickle make out of the mirroring, and so I was able to do that.
What are you using? You're using
Yeah, I'm pretty sure the bulb blew because I think I even hear it still on.
Yeah. Is there an HDMI?
They had one, but it was just making my screen blink. That's all that was happening today.
Okay.
So.
Let me see.
Oh, you mean HDMI on the other side?
Yeah.
There might be one back in the adapters back in there. They've got a box in that cabinet. I mean, my laptop takes an HDMI connector.
Because there's a giant thing you just outside.
If there's a cable on it, I can plug into it.
Yeah, there's HDMI on
So if they, yeah, I mean, well, yeah, if they've got one like a male connector, I can plug in my laptop. I don't know if they have that. Anyways, you were saying?
So I was able to put the HTML mirror in for the beautiful, and I was able to get a sentence to say this is a beautiful, and then beautiful. But Rebel didn't make it. So I did type of, had a return info, and it said type of info, and it said undefined. So I think it's supposed to be maybe a string. So when your return is not correct, is there like a maybe like a checklist of what check first or second to find out why that's not?
I got a new classroom. The Momentum folks have allowed us to borrow theirs. I think.
Nice. That's awesome.
There's a projector in there if you guys want to move.
All right.
Oh, cool. Okay.
Yeah, we'll swing over there. And I'll just leave this streaming. We're going for a walk. So I may as well talk with you while I'm doing this too. So, I mean, the first thing to look at is just what does your return statement have, right? And so if you're seeing something off like that, maybe try returning just a very simple string from it just to see like, okay, did that change my return? What I'm checking if I check the type that I get back. And that might help you, at least get started. But after that, I mean, troubleshooting is looking at what you actually returned. Like maybe your code's not getting hit. Maybe there's an error somewhere earlier, and so it's returning undefined.
I always use a Python tutor to find out how it. So, and I was getting the nice sentence whenever I tried putting in different things, but it's still the same.
The challenge is, I mean, again, the common one there, even after it's gone through a couple times, is it's common for somebody to be doing like a console log inside of the function as opposed to returning the value from the function.
So Jessica put the this projector on, and I think you just have to connect in with one of these cables.
I don't know what that is.
All right,
Yes.
let's see how this works.
I'm very close.
This is like Mac computers.
Yeah, any of that works. But I have an HDMI. I've got an older Mac, which doesn't have the evil.
Kind of evil because I'm going to convert.
Oh my gosh, I still need one of these. This has got to be cheap, right? I need this for teaching. Oh my gosh.
Right off.
What?
Right off. So we just have to make sure to close the door.
Okay.
And leave everything the way we found it, just because this is not our space. Don't try them.
Thank you so much for checking with them.
There's a friend in my place.
Yeah. All right, I'm sold on this toy. Anyways. All right. Starting again. Hello, everyone remotely. And I'm not screen sharing anymore. Let me try and change that. Okay. Hopefully we're good now. So here's what we're going to be going through today. We're going to do a review of some of the stuff that we did before. Some of this is, I want to try and, I've gotten some feedback, which I think is really good about wanting to do more hands-on. So there'll be some opportunities for people to work through even some of this new stuff. We'll work through it collectively afterwards as well, just to try and have you guys do some of that work right now. So there'll be moments for people who are remote where there might be a good gap of sort of quiet, but if you want to even submit your stuff up to Slack at that point, that would be great. We review bracket notation and iterating on objects, factory functions and constructor functions, and then for new concepts today, we'll introduce the array for each method Remember how I said the for loop would make you upset that we were writing everything with while loops? This one will make you, once you understand it, you'll be like, why would I ever want to use a for loop for an array ever again? And then we'll talk about objects, and really the emphasis today is on object inheritance and working with that. That's what we're going to get to at the end is working with the prototype chain. And that's one of the powerful concepts, sort of object-oriented programming. So we're starting to build on all of that. So let's start with bracket notation and iterating over object properties. All right, if we have this album object, which just has some properties on it, and if you've never listened to it, you definitely should. It's amazing. We've got pet sounds, right? How can we iterate over the properties of this object dynamically and print the value of each property? So the first question here, and it's okay, this first section, I don't know, I'm going to be doing this up here, but I'm going to leave a little bit of time for people to answer, is does anybody remember how we can, let's do it bit by bit. Do you remember how to iterate over the properties of this object? How can we get all the properties on an object in JavaScript?
Use like a method that's object keys and the object.
Yep, that's exactly what it is. To get the keys of an object, use the object.keys method of the object. That is confusing, but that's what it is. It's the object.keys method of the object. So if we were to take our code, let's go ahead and put this code bit by bit into an editor. I also got some great feedback about trying to actually create new notepads for each bit of code so that they can be saved instead of putting them all in the scratch. So I'm going to be giving that a go. It might take a little bit of practice for me to get it down smoothly, but we've got our album, which is the basic bit here. Then we'll see how close I type stuff out that I typed just an hour ago when I do it again. The next thing we want to do is get the keys off of it, right? So we'll do keys equals, and we said it's using the object, and then we have our album. That's what we want to get the keys from. So now keys should be an array of all of the keys from our object. And so that puts it in sort of a state that we're pretty comfortable with. We're relatively familiar with walking over an array, right? So we can do for var index equals 0, index is less than keys.length, index plus plus, and I don't know what we want to do. We want to print something out. Keys of length. So this is just, I need to give it a name. What will I call this? Bracket notation and key iteration. All right. So there may be something wrong. Let's see what we have though. Let's see if we work right now. Sure enough, I've got a problem in my code. Length is not defined. Oh, not length. I want index here. Let's see. Nice. We can step over each key that way. Does this need to be zoomed in anymore? Is this good? All right. So that lets us step over each key pretty easily. Let's go check and see how close that is to what I had in my slide. Pretty much the same. I just changed this.
Right in the back of it, maybe. I don't know. Sometimes my computer does that.
Let me see here. It has me on, but maybe it's not. Maybe I don't have a good signal here.
Are you, it's like moments.
I can try and switch. What is that?
Moment.
Okay. I don't know if this is, oh, it does look like it's the same stream. Yeah, I think it was a network issue, and Hangouts probably automatically switched off my video to try and give more bandwidth to the audio. So, all right, let me switch over. People see me now? Seeing some okays? Not sure. It looks like maybe the same stream link worked. So if you're still on it, I hope it worked, because then I can have just the one video that I upload, even though it'll have this awkward moment.
They're saying that it's still only sound.
Still only sound. All right. Okay, well, let me do this. This won't be perfect, but let me get the lesson uploaded. This will be a rough approximation. I'll keep streaming the video, but I'm going to go ahead and push up the where am I? Everything's so tiny. Okay, so I pushed up the latest code up to GitHub, or the latest notes. So if you're not getting the stream, I'll go ahead and post this link. You can hopefully follow along with the link to the lesson notes as well. All right, so back to where we were completely lost, right? How do I use these keys to read the properties? We're already doing that, but we want to make this a little nicer code, because this is pretty ugly. So what I'm going to do here is I'm going to assign some variables that help make this a little more readable. I'm going to get the property name, and that's just the key at the index that I'm at right now. And then I'm just going to get my property value, which is my album of property name, the value of the property name. So at least to me, that reads cleaner. And then I'm going to steal my line here, because that was just a little simpler. So then all I did here was change the code, right, to make it look a little different. I just said property name property value. If we look at the code now, it's similar to what we were doing before, but I hope you get the idea. Let me just, do people feel like this is easier to read now in terms of the code by assigning these into some variables with a different name instead of having it all one line? So it seems trivial, right? You're like, okay, don't emphasize that. I can't tell you how many times when you're writing code or anything else, that you're not thinking about how easy it's going to be to read this because you're just putting something together, and somebody else comes down a month later to work on that code and has to spend an extra 10 minutes staring at it to figure out what's going on. So emphasizing trying to make stuff nice and simple, give it good meaning. Even when you go back to your code, it's going to be a lot nicer if you go, oh, okay, this is doing this thing, right? It's a nice contained item. All right, so that should be just review. Now we can make this even simpler and make it read a little better by introducing yet another thing that we haven't introduced. And I still want to see people send me descriptions of some of the functions on the built-in objects. This is one of them that is really handy for us. I've seen a couple, right? I saw shift op an array. This is another one on an array. It's called the for each method. And the for each method is just another way to iterate over the values in an array. We've already used while, we've used the for loop. For each is another nice way to do this. One of the great things about it is it hides all of those details that we've been dealing with. Initializing an index, checking if we're less than the length, incrementing that index, all of that disappears when you use for each. And it really increases the readability of your code. Just like the little change I made just now, when you have for each, your code almost reads like an English sentence in terms of what you're doing with it, which I think is really nice. It takes away all those details that you have to try and understand and replaces them with something that's pretty readable. But it does take a little bit of getting used to because it works different than some of these other approaches. What happens with the for each method is it takes one argument. Well, I think it can take more than one, but initially the usual approach is it takes an argument, which is a function. And we haven't really done this before in any of our code, so this is a slightly new concept. We've called functions, but we haven't passed a function as an argument. So it'll take a little getting used to, a little practice if you want to get into this style of coding, but it's really powerful. And then it's going to iterate over the array, calling that function with each value. It's essentially hiding all of those details of what's going on. So I think, you know what, I wasn't even planning to do it this way, but I think it would be great. Let's take what we have here and let's implement our own version of for each. Well, I guess we'll call it first and then we'll implement our own so that you can sort of see what's happening a little bit at least. We're going to basically take all the same code that we had, except we're going to change some of what's going on in here. So we're getting our keys the same way we did before, but we're going to take this concept of printing an item or the properties of an individual property, and we're going to encapsulate that inside of this print item function. So you notice this is really just doing the same thing. Let me try and leave a lot of variations of these floating around. So I'll try and put all this in another file. Maybe call this array for each. I'll need to do some more organization on this, but we're going to get our keys, and then, no, I don't want all of that. It's got all of this in there now, so let me copy this again. Normally I'd type this stuff out, but I want to make sure I'm moving through it. So if we've created this nice print item, or print, maybe I can rename it better. Print property, and it's getting a key. What we're going to do is get rid of pretty much all of this for logic, because that's all going to be hidden inside of this for each behavior. And we can do keys.forEach, because it's a method on an array. What we're going to pass in is what we want to do on each one of those keys. And what we want to do is just print the property. Let me see if my code works. I don't know. Oh, I don't want to do get. Okay. That's right. You see it does the same thing that we did before. But now it almost, if we ignore this little bit here, what's going on inside of our function, this gets into that encapsulation behavior, right? Is this can almost read like an English sentence. Unlike before where we had all of that while loop detail or all that for loop detail, it's just, you can almost say, for each key, print that property or print that key. So it's doing something for each one of those. And what's weird about this, again, that we haven't done before, is print property as a function. So instead of invoking our function, we passed a reference to that function into this for each, and then this for each on the array automatically called it for every item on that array. So it sort of did that for you. So let's, just so that you get a feel for what's actually happening there, let's go ahead and try and write our own version of this for each instead. I'm going to write it, not attach it to anything. So I'll say for each. And this is going to need, since I'm not attaching it to an array, it's not going to implicitly be able to reference that array. So we'll pass in the array, or we'll call it a list. And then we're going to pass in the action to take. Action to perform, we'll call it. So the way that we'll implement this is we're just going to go back right back to what we had before. Let's create this for loop that we had of our index equals 0. Index is less than list.length. Index plus plus. We're just stepping over this bit by bit. And then what we'll do is call the action to perform on the list index. So that property. So that's a lot like what we had in our earlier for loop here, where that's keys index. You could call this keys if we wanted to make it look the same as what we had before. And now instead of doing keys.forEach print property, we could call our for each, pass in our keys, and then pass in print property or a reference to that function. Let's see, I may have a bug in this, never know. Nope. It looks like it works. But what we did there, even by ourselves, is we hit all that ugly complexity of stepping over an array and getting everything off of it. And now we've got a nice little function that we can reuse instead of doing that over and over. How comfortable do people feel with that? The idea of passing a function, if you're familiar with other programming languages. Who's familiar with other programming languages again? All right, have you ever passed functions around before like this? Yeah? That's pretty rare. Usually in a lot of other languages, you don't necessarily do that. Or if you do, you have to have a special type of function. It's called like a lambda or something like that. What? But a lot of times you don't actually pass just a reference to a function, right? You may invoke something, but you're not passing it around that way. Now, you feel like that's, I mean, I feel like it's easier to read, but you feel like it's easier to understand what's going on when you're passing stuff around like that? Or is it a little bit of a challenge right now? So this is where JavaScript doesn't stick with one paradigm for coding, right? JavaScript really has multiple paradigms for how you can code in it. And this is more of a functional pattern for coding versus an object-oriented. The rest of today will probably be spending on object-oriented coding, but This is a pattern that comes from the functional world, and it does add some really cool power and flexibility to the way that you can work with codes. All right, let's talk about creating objects. This will pretty much be the rest of the class. We're going to be working with creating some objects. So let's review creating objects using the different approaches in JavaScript. We'll be creating the same object using each approach. That way we focus on the syntax instead of the properties. Surprise, I'm a nerd. Okay, probably not a surprise, you know. I think you guys have noticed that, right? But let's just, that point is I like to participate in nerdy things. I like to do things like read, debate what's gonna happen in the new upcoming Avengers Endgame movie, playing RPG games with my friends. Okay, so to appeal to my nerdy hobbies, I get to make you guys do something. We're gonna be creating objects that represent a character in an RPG game. That's what we'll be working with. So in an RPG game, there's a lot of different properties something could have. But let's stick with these ones for today. And I'll write these on the board as we step through the other stuff so that people can remember what we're doing. But the properties we're going to be putting on our object, we want our objects to have are name, experience points, just as XP, level, class, strength, and intelligence. So I'm going to get these written over here in just a minute. But as review, I want to, we'll do this as hands-on exercises and give a little bit of time for each one to create an object that has these properties using each one of these different syntaxes that we've already learned for creating objects. So the first one, the one that we've done the most of so far, is object literal syntax. So I want everyone to go ahead and just work through, on your own computer, or if you want to work with somebody else, it would be great to work in pairs as well in case you feel intimidated by doing this just on your own. Go ahead and create an object. I'll go write these on this board over here just for the moment, so because as we move forward, I don't want to keep going back and forth too much, but using object literal syntax. And if you're remote, please post something in Slack after you get it created. And I'm not saying what the values of those have to be. These are just the key names. Get my phone out so I can see when people post stuff in Slack too. And when you finish, you can just put your hand up. It doesn't need to stay up, just so I can get a feel for when people are done with this. Also, if you have any questions about what those properties are, let me know, because maybe people haven't played RPGs and they don't know what a class is. What?
I don't know how to roll like XP. Like, what do you mean by XP?
I don't know. Like give it. Let's go with a number. How much experience points has this character earned?
Like in total, or like by level? Because I'm like World of Warcraft.
Yeah, it doesn't matter. Give it whatever value you want.
Okay, all right.
Give it whatever value you want. I mean, yeah, if you're like 60th level on World of Warcraft, I don't know. That's millions, if not billions. I don't know what the.
Yeah, it's a lot. It's a lot.
I know it's not a linear scale. It's like.
XP gets a little bit foggy after you get to those higher levels.
That's sort of the point. We're going to build on it.
That's a good, yeah. Yeah.
Pardon me. Pollen season has begun. That's not killing you. This would kill you. Let me see. Let me see if I can find the GIF I had earlier. Class is a reserved word. Yes. Thank you. Class is a reserved word, which means that you can't actually have class because it's going to cause a problem. Now, there's two ways to solve this. What? You can put character class. That's good. I was expecting somebody. So there's a few ways to solve it, actually. And I'll go through some of them up there. So let's change it, and I'll post on line 2 for this. Let's change it. We can't have class. I will use class in just a moment to show you how you actually could, but let's do character class. That's perfect. I wanted somebody to say something like that. Let me see if I can find it. There we go. This would kill you. Oh yeah.
Oh my.
Okay, let me go ahead and change the slides too for the people who are remote. If you didn't catch that, class is a reserved word. You can't actually use class. So instead, we're going to use, let me find it here. And I should be using lowercase on each one of these. It automatically uppercases the first thing, and I always forget to change it. All right, update this. There we go. Sounds like some people are getting done. All right, what? You got something wrong?
No.
That's okay. You can ask someone, talk with each other. All right. Yeah, I'm seeing some good ones here. No properties wizard. Oh.
So how are these supposed to be? Like numbering?
Let's say they could really be whatever you want, but let's go with, if you want to follow along the same way, we can make strength and intelligence, level and experience points numbers, and then name and character class are strings.
Yeah, that's good. Yeah, you want to make sure that's right.
And you can use whatever range you want for strength and intelligence. I'll be using something where like 10 is average. That's sort of like the traditional Dungeons and Dragons model, I guess. So, what? Dunce for intelligence? Oh. All right. Good. Moving through. How many have gotten done with? Got a character so far? All right. We'll keep working on it, and I'll go ahead and create the first one over here for us collectively. Let me need to tell it this is JavaScript. And then I'm going to call this, let's call it character objects. So my first one, yeah, we'll call him the wizard. I don't know. So wizard's name is going to be It's a good name for a wizard. What? Harry? All right. What do we have? He's got some experience. I don't know. He's got like, he's pretty young still. He's got like 100 experience or something. Level, he's level 1. He's going to reach level 100, but he starts off low. All right. Class. So this was the gotcha I sort of put in there. I'm glad somebody brought it up. So you can't just put class here and you'll see it complain. It may not complain right now, I don't know, but you shouldn't just be able to put class because it is a reserved word. It could cause problems. And so what you'll see is I can maybe put it on here, but I'm probably not going to be able to read it off. So what's his strength? Like average. But his intelligence, it's going to be like above average. It's like 14 or something. I don't know. And if I tried to, I should be able to see the problem here. We'll see. I don't know for sure, but this is going to blow up. It's able to read it off. So it works on an object, but it is generally bad practice to do that. So there's a couple ways to protect against this. One of them is sometimes you've got something that you're just not going to be able to read, and you can use quotes if you really want to have it there. Because you can quote the property name as a way to put something in there that's going to cause you problems otherwise. It's not usually best practice to force yourself to do that. So that's why switching to something else instead is usually a better name. It's not, oh, that's right. It's not that class on this is going to, class is a reserved word in JavaScript, but class is also a reserved word in HTML, and then you can run into even another set of problems, and so then you get a whole bunch of cross problems between both environments too. There we go, we got a basic character created using object literal syntax. So let's move on to our next one. Go ahead and create a character, same set of properties, but this time create it using an object factory function. And remember, this is what we talked about in the last class. An object factory function is really just a function that returns an object of the type that you expect. So with that structure in this case. And preferably, although I don't define it here, don't hard code the values inside of your factory function. So don't, like you could, let me be the most basic version of how to do this. You could just return like, oh, just wrap this inside of a function and return it directly or something. Instead, pass in the values for name, experience, level, class, strength, and intelligence as properties for your function, and then set those on the object that you return. And feel free to ask for any questions if you want help, if you want an example of another object factory function, again, because you don't remember, let me know. Someone is using some newer JavaScript syntax.
I wonder if the character reserved word in JavaScript. Here. Cool. Do you need colons? Yes, you need colons. Yes. When you're doing an object literal inside of the object literal, you use colons to separate the key from the value. When you do it outside of it, so like if I read,
That's a good gotcha, right? That's a very common one. If we wrote this, we could write this same thing in a different syntax, but inside of the object literal itself, you use a colon. I could rewrite this, and we're going to do that again in a moment. Instead, where if I change this and I said wizard.name equals Harry, I would do that out here and refer to each one. Like if I'll just do it with one of the properties. So I'm going to set his intelligence out here. And I can just get rid of it here. So the syntax is a little different when you're inside of the object literal and when you're outside. Yeah, that's it. That's a good gotcha. I make that mistake all the time. Yeah. So as highlighting was when you're inside of the curly braces of an object literal, you use the colon to separate your key from your value. And when you're outside of it, if you want to set a value, you just use an equals after the value. So it's a common gotcha. No joke. A lot of times I'm writing code and changing from one format to the other and just forget to change that stuff. Anybody have their object factory working? No? All right, this one's more challenging. Next one might be too much. Maybe we'll do that one collectively. We'll go a little bit longer. We'll go at least till 8. I need to do more in-class coding.
want to show us a shortcut?
What?
For when you,
Oh, shortcut for what?
when you highlight all of the words that are the same and you type it and they all change? How are you doing that?
Are you guys in Cloud9 or?
Yeah.
I don't know how to do it in Cloud9.
Oh, okay.
Let me see if Cloud9 has it.
Or so,
I think it's just command.
Let me see here.
so what are you doing then? Yeah.
So it looks like Control Alt
I think so.
and the left or right arrow key
Yeah.
might work in Cloud9 for multi-select. What?
Yeah, right. It works.
Yeah.
The factory function does have to return an object, right?
Yes, the factory function should return an object. Do you get this?
Yeah.
All right. We're getting some people there. All right, you guys ready to work through this one collectively, or you want to take a little more time? What?
Yeah.
All right. I think the next one we'll probably just go over collectively because this one at least should follow a similar pattern. The next one is using a constructor function. You've only seen that once, so we'll probably do that collectively to help reinforce it a little more instead of having you guys try and work through it just by yourself. So here's what I'm going to do. I'm going to create a factory function. I'm going to call it a character factory. And I know that I want to pass in all of these values. So I'm going to just give properties for each one of those. Name, experience, level, character class, strength, and intelligence. So yeah. And then all I need to do is take those properties that I passed in, and I'm going to return a new object. So this is just like what we had up here, except instead of setting the properties, let me do it this way just to use the other syntax. Var, call it my character, make it a new object, and then I can attach each one of these properties to it. So I can say character.name equals name. Character.experience equals XP. I could have used the object literal syntax in here too. It's really sort of interchangeable. Character.level equals level. Character class equals character class. Character.strength equals strength. Yeah, it's a little verbose. That's why I tend towards the object literal syntax in a case like this, because it's a little less verbose. And then I need to return something. So I need to return the new character that I just created. And now when I use that, I need to invoke that. So I need to say, what am I going to make? I'm going to make a, we're going to invoke our character factory. And the name is going to be Conan. And the experience is more experience. And his level is, I don't know, like 5 or something. And his class is barbarian. His strength is like 19. And his intelligence is like 8. And we could just check something off of that if we want to, right? Like Conan dot character class, just to make sure this is working. Let's see if this works or if I have a bug. Yeah. I can look at it, print out all of them as well if I want, but that's an example of creating one of our characters using a factory function. Does that make sense, the way that we did that? And what we have now is something where we can call it over and over and create characters if we want, again and again, pretty easily. And we could change some of this behavior. Like we could say, because JavaScript functions are very interesting, we haven't talked a lot about this, is maybe there's default values. Maybe we assume like the only things that matter are name and character class. And so what I'm going to do here is maybe change the order of my arguments to my function, which means I have to invoke it the right way here. Got to change where I call this. So this needs to be my second argument because it's name class. And get all of this syntax right. And what we could do is say there is an experience and a level and strength and intelligence, but if somebody doesn't pass those in, I'm going to set some sort of default value for those. And there's a lot of ways to do that. Don't worry too much about this syntax. This is what's known as like a short circuit syntax. But this would be a way, for example, to do some default values for some of these things. Strength, default to average, intelligence, default to average. You don't need to get too engrossed in that exact syntax, but that's another nice thing that you can do. When you've got sort of factory, you can set some defaults. You can have some additional logic in there that you can't have in just an object literal. So now I could create, I don't know. We're going with, you know, like John Doe type person, just nobody. And he's just a salesman. And he doesn't get anything else passed in. And so he's actually, you know, if we were to, wish I had a nice, I'm sure there's a nice little built-in way to just print everything on something. Oh, look, I have all of the logic right here. Let me just steal this. I'm going to change this a little bit. Get everything off of John, and then here, I'm going to cheat a little bit. This function is bound to something that it shouldn't be bound, but I'm just being lazy. So I can see everything there. Let's see what I get. I get all the properties of John, and you see it just defaulted to those nice values. That's something that we couldn't have easily done with our previous version that was all syntax or object literal. Any questions on using a factory to create objects? Should be very similar to the object literal syntax. It's just inside of a function that returns it.
Those default values, that syntax still work if you were writing your factory function using object literal instead of
It would. It's not very common because usually when you're in object literal, like at least it depends. If you're writing it like this where you know the values, you're not going to do it because you know that you have something. But if I change this and if I did something like this, so now, oh, I need to get rid of all these too, change these to commas. Oops, now it's wrong. Something's wrong here. What do I have wrong? Oh, it wants to, there we go. It was the IntelliSense setting stuff. So if I created my character this way and then returned him, it should still, nope. You don't have to. JavaScript, you can leave it or not. I have a habit of usually trying nowadays to leave the trailing comma. That way, if I need to add another value later, I don't accidentally break my code, because I've done that so many times. Enough, hundreds of times. This used to be a problem. Actually, old versions of Internet Explorer would fail if you left a trailing comma sometimes. It depended on where it was in your code. It was really annoying. Doesn't happen anymore. Welcome to JavaScript. All right, so yeah, you could do it that way too, where you'd still get your default values. And so, that's just another way to have written the same bit of code. So let's do it one more way that you guys at least have been introduced to. And then I'm going to introduce yet another new way to create objects, but I'm really only doing it for the simplicity of teaching you about object inheritance with it. So object constructors, we introduced this in the last class. And a constructor is it's just a function that you call with the new operator instead of you calling it directly. You use new when you invoke it. By convention, a constructor function name starts with a capital letter as opposed to a lowercase letter like most functions. And the difference with how it works is inside of a constructor function, if you want to set properties on what comes back when invoked with the new, you set those using the this keyword, referring directly to the object that you're going to return. So if, being a properly lazy person, except now because I refactored this to use an object literal, not quite as easy. I don't need to return something if I'm going to make this a constructor. And I'm just going to call it character. Because usually I'd say the most common pattern is you just name your constructor sort of whatever it's going to return. Oh, this is a character. It's a character constructor. I'll just call it character. And I'm going to invoke it. Oh, I lost my intelligence. I need to change this anyways, but I will just invoke this the same way, or I'll invoke it using new, but the way I'm going to set my values is a little different than, see, this is where I'm going to show my shortcomings, because I don't know how to do proper multi-select this way, I think. Shift. It's Alt.
No, it's
It's Alt, I think. There we go. Looks like it's working. There we go. So if I want to set properties, I'll do this dot to set them on it this way. And then let me select each one of these. We're going back to equals. And then again, each one of these needs to go back to being a semicolon because these are separate lines. Should have left the previous one because now this is broken. So I'm going to create Conan this way now. And the difference is I invoke it with new character and pass in the arguments that I need. This one's not going to work, so let me delete that. I don't care about you. And because this function has a problem with it where it's referring to something globally that it really shouldn't, I'll iterate over everything on Conan. I'll make this Conan. Let me see if I have any bugs here. You notice there's a couple interesting things, right? We use this to set things, and we didn't return anything from this function. I should also probably change my indentation. So let me see here. I should have left the other one around for you guys as a reference. Sorry about that. But there we go. We've got all of the properties of him being printed out. And that's using what's known as a constructor function. Again, the key difference is here. This is how you refer to stuff in it. New is how you invoke it. You usually, by convention, it's an uppercase. There's no rule that it has to be, but that's the way that people commonly create them. Any questions about creating an object using constructor function syntax?
yeah, capitalize, character.
Where is that?
On line 24, where you got.
Line 24. You don't have to. There's no requirement, but it's a strong convention because people are used to seeing a function with a capital letter and assuming that it's a constructor. So it's, I could go on a long rant about stuff like that, but it's a popular convention, so I definitely encourage you to stick with that convention so that it's, A, when you read other code, you'll get comfortable with it, and B, other people reading any code you write would be able to sort of interpret it that way. Any other questions? That's a good one. All right, so might take a break after this, but I'm going to introduce one other way to create an object. I told you, JavaScript is a little schizophrenic. You know, other programming languages, it's like, oh, you use new to create your object. JavaScript's like, here's a dozen ways to create an object. Have fun. This is object.create. It's a method on, again, the object. It's another way to create objects. At first, it looks like it's just a more complicated method to create objects, similar to object literal syntax. So I'll go ahead and just show you because it's, again, very similar to sort of this object literal syntax. I'm going to create an object this way. Let me see here. I'm going to get rid of my, what's another good fantasy character? I'm going to create like, yeah, I was thinking like, I was going Lord of the Rings. I mean, it is my favorite book. So we're going to create one that way. So we're going to create let's go like Legolas. And we're going to just do object.create. And what that's going to do is basically be the same as if I had done, that's very similar to just saying like, here's an empty object. Now I'm going to add all my properties to them. I'm going to say, Legolas dot, what are my other ones? Character class equals, well, that's his race. I don't know, he's like an archer. Yeah. We didn't have race, we're missing one of our properties. Legolas dot experience, he's got like a ton of experience compared to the others. What? Over 9,000, yes. No, this is not Goku. All right, now I've shown my geek legitimacy. All right, what's his strength? His strength, I mean, stronger than average, probably. Not amazing. His intelligence is like more than average, not amazing. Now we're missing something like agility or something that, you know, really highlight. This is just another way to create something, this object.create. All that did was, and I'll show you that again here. I should really clean this up so that I don't have to keep changing this value, but it's fine right now. You know what I'm going to do? I am going to clean it up so I don't have to keep changing that, but I'm going to cheat a little bit. I'm just going to call it temp. And then right before I do all of that, I'm going to set whatever I want it to be. It's just a reference to the same object. Hopefully that works. Oh, it's going to blow up. No, that should be okay. I've got something wrong here. Let me see. Oh, I think I have to. Okay, when I call create, it does require a first argument here. So I have to pass it something. And what I'm going to do is just pass it this empty object. So that'll be the major difference here. All right, there we go. So we've got him back out, right? Again, what I said is it looks, if we highlight just this stuff, that doesn't look much different than like the object literal or whatever. We just created something very basic here. And all this was at this point was just an empty object. But we'll come back in just a little while to the value that we have from working with object.create. It's just the easiest way to teach sort of the next bit of logic that we're going to build on top of. And the key part of that is exactly what I had to do that I was missing. Object.create method has to take an additional parameter, and that first parameter gets set as the prototype of the object that you're creating. And that's what we're going to cover in just a minute, is what does that mean? What does it mean to have a prototype, and how does that affect your code? So we'll dive into object relationships. I want to make sure, if people need to take a break, you can. If not, we can keep going. I know it's already getting late compared to usual. So, all right, people looking good? Cool. We'll keep moving. So let's talk about object relationships. The two major types of relationships that objects have to each other and how you work with them. The first one, and I put it first here, even though it's not usually the one taught more when you're teaching computer science and you're teaching object-oriented programming, but it's the more important one and the one that you should use more often. This is in general, it's better to think about building up objects from other objects, object composition. So you build up, in the last class, for example, we had our person object and they had a vehicle object inside of it. So they had a reference to this other object. Now that one, sort of makes sense. Oh yeah, person has a vehicle. But if we take a vehicle and we try and break it down conceptually, you can think of all of the other objects that a vehicle is made up of, right? A vehicle is composed of like an axle and a steering wheel and wheels and an engine and a chassis. And all of those are separate objects that you put together to build your vehicle. So the vehicle's properties, for the most part, are all of these other objects. And really that's probably the most powerful capability that you have to allow you to represent something more complex, is to think about making small, simple objects that you're working with or starting with and building these more complex things out of them. If instead you try and put everything into one object when you're building stuff, it's going to be unmanageable. It's going to be something that isn't really reusable. You're going to be stuck with just this sort of unmaintainable bit of code. But if you think about, oh, what are the pieces of this, and then I put those into my other object, that will really help you compose your code more effectively. And it's also by far the much easier one to comprehend. It's a lot easier to think about, oh, this object is made of some of these other objects. So if I create all these pieces and put them together, I've got the bigger object that I wanted. The next one is the one that's a little, I thought I had a typo for a second, is the one that's a little harder to understand and to work with. This is the one that really makes object-oriented programming tricky, and it's also tricky to get right when you're working with it. A lot of times when you're learning object-oriented programming, this is the one that's emphasized. It's talked about a lot and focused on, and a lot of times, honestly, the examples that they use for when you would want to use object inheritance are not really good examples for when you would want to use it. I'm going to do the same thing. And the problem is it's hard to have good examples for it. It's much easier to show the bad examples because it emphasizes what inheritance is and how it works. But it's much harder to emphasize when you would actually want to use it because it's very much a specific tool. But object inheritance simply means that objects can inherit properties, state and behavior, from other objects. That's really all it means, is an object is inheriting behavior from a different object. This is done differently in different programming languages, but the concept itself is the same. And one of the nice things about this is inheritance can allow for objects to share a common interface. And we'll get into a little bit of that, but the idea is if I'm saying it sort of inherits behavior from another object. So if you have an underlying object that has a piece of behavior, then any other object that inherits from that is going to have that same piece of behavior. And you can think of that bit of behavior that it has as an interface, something that is common and the same across everything. Inheritance can also reduce code duplication, which is what you'll see emphasized a lot by allowing you to reuse existing code. But again, it can be misleading or dangerous if you do it wrong. So it takes really a lot of practice to end up doing it right and not sort of code yourself into a corner when you're working with it. But the key here for JavaScript is in JavaScript, object inheritance is not achieved using the classical inheritance models, which involve either in, say, like C#, you have like implements or inherits. I can't remember the exact terminology in Java, I think might be about the same. In JavaScript, inheritance is achieved by the use of the object prototype. So the object prototype is all objects in JavaScript, and we looked at this a little bit before, have a prototype. So every object has a prototype. You can directly access it using that sort of __ proto that we showed, but that is actually a deprecated standard. It could be pulled from browsers at any time. There's an indirect way to get to it. I have to look that up in a minute. It's like get prototype of on the object, I think. I'll double check, but the key is every object has a prototype, and the prototype can have one of two values. The prototype is either, or it can be one of two types. The prototype is either another object or null. So essentially what you get, sorry for the people who are remote, because I'm going to use the whiteboard for a minute to sort of visualize this a tiny bit, is let's say you've got a string object, which is one of the common objects that you work with a lot in JavaScript. Or an array. Let's go with an array because it's more obviously an object. So you have an array object, and the prototype of the array object is actually the object prototype. And then the prototype of the object prototype is null. So it's there might be another layer in there, but I think it's just those two layers. But it can be, we could put another layer in between and another layer in between. And you could have as many layers as you want of prototypical inheritance all the way down. So you could say, we could create another thing that has the array prototype as its prototype, and that way it will have access to that functionality. And then that will still have the object prototype, etc. The key to why this matters, what's going on when you're working with prototypes, is that every object inherits the properties or state and methods, behavior, from its prototype. So anything that's on the prototype, it has access to as well. And when JavaScript is looking for a property on an object, it's going to look on the object itself and see if that property exists, whether that's just a state, some value, or whether that's a function. And then if it doesn't find that on the object, it's going to check the prototype to see if that value exists on the prototype. So it's sort of going to walk its way down this chain. And if it doesn't find it on that prototype, it's going to check the prototype of that. And then when it finally hits null, it knows that it's done. That doesn't exist if it didn't find anything. And so it tells you that it's an undefined. Let me see if I can show a good example of this. Let's see here. I don't know how this will work out because I'm just winging this. Let's see. Let's just create an array. Those are all prime numbers. We've got primes. I'm actually even, because I get better syntax highlighting for that, or because I get better code completion, I'm going to use the dev tools in Chrome because it gives me a nice code completion. Nine isn't 1. All right. If I look at primes, I can see a list of properties on my array here. I've got length, and I've got concat. I've got constructor, which is a little interesting. Entries, every fill. Oh, there's that for each that we learned about earlier today. If you really want to play around and learn just what exists or take a look at stuff, this is a really useful tool as well. Hop into the Chrome Dev Tools or anything like this, and it'll give you a lot of times some nice code completion to try to help you out when you're typing. So I put the dot in there after I had this array, and now it's showing me stuff that's on it, right? So this is really cool. I've got all of these different properties available on it. But let's check out, I'm going to create another object. I'm going to create an empty object. And this is really interesting. Look at some of these things that exist on my empty object, for example. I didn't define a toString anywhere on this empty object, right? That object has no properties that were attached on there at all. So where is that toString coming from if I didn't define it on my object? Well, the key there is that's actually coming from the prototype of this object. So it was walking down the prototype chain and looking for what's there. Now let's check this. You may not see it here because it doesn't always show you everything. Look at there, I've got a toString on my array too, and it does something. Now it was sort of hidden from you. Yeah, I don't know why. Chrome just didn't want to show it to you, maybe. Maybe it was, oh, it's down there. It was just below. This scrolls. So if I look at, I think this is the right syntax. If I do get prototype of my empty object, it returns to me whatever this prototype is. Now, what I told you was, stuff's going to inherit from the object prototype. So I can check that and see if that's true. I can say, did this really inherit from the prototype of the object constructor? And sure enough, it says that that's the same object. So they're actually pointing at the same object. And if you remember a few classes back, we talked about object uniqueness, which means that these two are not referring to two objects, like the prototype of empty and the prototype on this object constructor. Those aren't referring to two similar objects or objects with the same properties. They're referring to the exact same object. And of course, since JavaScript lets me break it, which, it shouldn't. I think it might let me really break it. Let's see if that's true. I'm going to do object.prototype.toString equals a new function. And what's this going to do? It's going to return I don't know for certain if this is going to let me do this, but it should, theoretically. Let's go back up here and look at our empty toString. And it tells me I broke the toString method, where before it was saying object, object. And that's because I went down to this object prototype, this object itself, and changed the value of this property on it. And then when I called it off of the empty object, since it's pointing to the same object, it also runs that same bit of code. So I sort of changed, by using that prototype chain and changing something on it, I was able to change behavior of multiple things all at once instead of having to change that in several different places. This is definitely going to take a while to get comfortable with, the concept of how inheritance works, how you work with this stuff, what's happening. But this is a very powerful concept. Again, this is another one of those things that if people are very familiar with another programming language, their mind might be blown because they're going, wait a minute, how could I change stuff on an object that wasn't the one that I just created or that I'm not creating? JavaScript lets you break it, Other languages won't let you get inside of an existing object and screw with them. JavaScript lets you do that. Let me get rid of this. Can I close you? I don't want to close all of Chrome. All right, I got rid of that. So we'll talk a lot more about that, but are there any questions just on this idea of the prototype being another object down the chain that you can reference?
Is it like a parent-child relationship between objects?
You can almost think of it like that, yeah. You can almost think of it like a parent-child relationship. It's a little bit like, I sort of want to do a hands-on, which I haven't done, but imagine, if you're in a row here of people, right? And what I do is I say, well, you're the top of the row, for example, and I give each person down the row a little bit of information, like some value or something that they can do. And maybe, to you, I give a name, we'll go back to our RPG character. And the next person, it's like the level and then like the experience. And so if I ask you, how much experience do you have? You may go, oh, I don't know that, but I need to check and see if somebody in this chain knows that information, right? And so, yes, the next person, oh, I don't know it, let me ask. The next person, oh yeah, I know how much experience, and then it can come back, right?
So basically, unless I have it, I'm going to check.
You're going to check on the prototype and keep going down, right? But then if I asked for example, your race, we realized we were missing that earlier. You'd go down that line, you'd reach the last person. They say, oh no, I don't have it either. Let me check. Oh, there's no one left to check. Nope, that's undefined. Nobody has that information for you, right? Nobody in this chain knows that value. So we all had to, but the key thing about how that works is other people could be built off of that same chain, right? So instead of just one path, somebody else could also refer to that last person and create a new unique path, right? Let me, again, sorry for the people on there, but you were whiteboarding it. In that example, you could say, oh, here's the base, and this thing knows, whatever the experience is. And here we created a prototype chain over here with a different race, and here's a name. And over here we did the same thing. We've got a separate race or something, and then a separate name. And you'll begin to see really fast why usually the things that you'll put in your prototype chain down here that you reference off of this are methods and not values. Because, wait a minute, these are two sort of unique things. How would they have the same experience, right? That's going to vary. So usually values, just your state, is on your individual object at the end, and it's methods that you get from farther down. But that's not required. What?
So most of the day will be sharing methods, not values.
Most of the time, you'll be putting methods farther down the prototype chain, not values, yes. And you notice even with what I had just pulled up in Chrome, like the array, pretty much all of the properties that were just values were right on that array object. And it was methods like toString that it was inheriting from farther down that chain. That's not a rule. They inherit every property, but typically when you're writing code like that, you're going to be putting the methods farther down and reuse them. So I probably won't get through everything, but let's revisit our character object from before, and we're going to go ahead and give him some behavior. He can change some things now, right? We want to give him some characteristics. So let's set some methods on the prototype of the object so that all instances of the same object will inherit those properties. All right, let's do this using a constructor function first, because this is perhaps the easiest way to do it. Any properties set inside of the constructor function, like we've been doing so far, are going to be properties on the object itself, but we can set properties on the prototype by setting them on the prototype of the function itself. And this is one area where I sort of regret the syntax of JavaScript, because it's confusing that your function, your constructor function, has a prototype property, and that sets them on the prototype object that gets created. But then the object that you create doesn't have a prototype property, right? It's on the constructor function, not on the object. So definitely confusing, the terminology that they used. I wish that that wasn't what ended up sticking and there was some other way to set that stuff, but that's the way it ended up working. So I'm going to leave this again, try and keep more of this around than I have before. Let's take this stuff, let's move it over here and get started. Methods on prototype. All right. So I'm going to get rid of my code at the start. Don't care about any of that. I'm even going to get rid of this character factory, just because in this case what I want to use is this character function. I'm going to sort of, for the sake of keeping stuff simple, I'll leave all that there. Move a little bit down here, and all right, so we're still creating Conan using this character constructor function. Wow, my brain just froze for a second. But let's say we want to go ahead and add some behavior to him now. We don't want him. We want to be able. I mean, this is an RPG. It's boring if all we have is state, right? That's boring if that's all we have. So let's add some additional properties. And the first one is I'm going to go ahead and add some sort of greeting, right? And this is a generic greeting. And I will type this stuff out too, because I believe it's much more useful when you type it out versus just cut and paste all the time for a class. But the way this works, I want to add some, let me move it up here first. It doesn't really matter, but I wanted to put it down there afterwards to show you. So the way you do this is, again, outside of this function itself, I reference the prototype property of my function, and then I can attach properties to that. So here I'm attaching this greetings function to it. And all it's going to do is print out the name. And you'll notice, this is one of the first times we've used this syntax outside of our like object factory or something like that. And that's because this is getting attached and it needs to refer to the object instance. There's also something interesting to be inferred from this, which is I'm telling you that this function, greeting, is going to be on the prototype, not on the actual object itself, but an object that it inherits from. But I'm able to use this inside of it. And that's because that gets into how it works, but even when it has to walk down that path to find a method to call, then when that method refers to this, it goes back to the start of that chain, back to the original object and says, okay, let me try and look for that again at the beginning of all of this. So now if we tested this out, I can comment this stuff out because I don't need to print all this right now. Let's see if this works the way I would expect. Does he give us a greeting when we run this? Out of here. And what did we call this? Methods on prototype. Oh, powerful undefined. I must have named my, I called it role here. I need to call it character class because I named it something different. All right, let's test it out. Awesome. And this is subtle at first, right? We'll keep going on this more, but let's go ahead and add another one. And this is a much more complex function. I want my characters to be able to level up in some way, right? I want them to be able to change and get better. So I'm going to write a function. And at first, again, I'll cut and paste this and we'll do a fair bit of rewriting on it. I'm going to do a function that lets me gain some experience, a method to gain experience. And it's going to take how much experience you're gaining. And I just decided on some arbitrary rules here. The arbitrary rules are you level up when you gain 1,000 times whatever your current level is of experience. I'm going to change Conan here to start at level 1 when I do this. And he'll have no experience at first. But the rules here, this isn't too tricky of code. I've got some logic inside of this gain experience. What it'll do is change the experience on your object, and then it checks if your experience is greater than however much experience you need to level up. Then it levels your character up, and it removes all of your experience that you've gained, because it's not keeping a running total. It's only counting how much experience you have from that level. So it removes everything that you needed to get to that level and tells you leveled up. And if you didn't, it tells you how far away you are from leveling up. So let's see if this works. We're gonna have him gain some experience, and he's gonna gain, I don't know, 100 experience at first, right? Let's see if this works. Cross my fingers, and we blow up because I have something wrong. I think I have level, not this dot level somewhere. There we go. I have a bug in my code. Wipe that, try it. We're 900 experience points away from level 2. And this is where we get into working with objects too, because Conan continues to maintain this state, so he can gain some more experience. You know, he gets in another, like, I don't know what he does to gain some experience this time, and this time he gains like 200 experience. And then he gains like 800 experience this time. And if we run this, see it introduces himself, you see him gaining experience, and boom, he leveled up. Because he had enough experience points to level up now. So now this is an ugly bit of code. If you're looking at it, this is another example. I'll probably end on this, and we'll have to come back and touch the end of these again. But this is a really ugly bit of code. I'm doing some things here over and over, and it's not very easy to read, right? You read this, and you can easily get lost. And so I would actually, and I'll do even more of this later, but I would do some refactoring. That's what's known as taking the code that you already have and not changing the logic of the code, but just changing the way that it's written so that it's easier to read. That term is refactoring. So I'm going to say, oh, I do this in like 3 different places. That's silly. What if I take this logic and I do it right up here? I do it in one place. Var XP to level up equals that. And now what I can do is I'm going to copy this, go into each place where I have this logic, and just replace it. And now it at least reads a fair bit better. It's a lot easier to see what's going on in each situation. Oh, if my experience is greater than the experience I need to level up, then I level up. And then I remove however much experience I needed to level up from my running total. And if not, then I tell you how far away you are from leveling up, right? And that shouldn't change. My code should work the same as it did before, which I'm testing just by running it again real fast. But hopefully, it's a little easier to read, right? And you can take this much farther. You can go farther and farther by pulling stuff out into meaningful variable names so that when you look at the code, it's something that you can sort of almost read as a sentence. And that's part of the reason I did that, is now it says, like, if my experience is greater than the experience to level up, do this. Otherwise, do this other bit. A couple other things to note really fast about the prototype is, I already showed changing the toString and how it changed everything. That same stuff applies here as well, is I can add these to the prototype even after I've created Conan. I'm going to copy this line too, just to show you that this should break. So if I try and greet somebody before I've added it to my prototype, that should break. Oh man, I hate how code works sometimes. Hold on. Oh, I didn't move everything, did I? I only moved the other one. Oh, I put this in the wrong place. Hold on. Let me do another trick here. Oh man, how does it work on my Mac? Is it this? There we go. All right, I need to move that up. Let's try that now. This should blow up, and it's telling me, well, there's no greeting function on this. I can't find anything, right? But then right below it, I go ahead and add that greeting method. And because I'm adding it to the prototype, and that's the same object that Conan inherited from, I'm adding it to that instance of an object. He has access to it, even though that stuff was written after I originally created him. So you can even change the behavior of something after it's been created by modifying the prototype path as well. Which is a sort of dangerous thing to do. I'm showing it more as an example of trying to show you the different aspects of how this works to have you think about what's actually going on in the code. But some of this is just things that you wouldn't actually do in your code. It's easy mistakes to make. Just trying to sort of help you think about how it works. So how are we feeling about the concept of the prototype being the way that you inherit stuff in JavaScript? Iffy, yeah. It's definitely different than classical object-oriented inheritance. We can simulate that. Being one of the few people who's actually fond of the way JavaScript works, I could, if somebody wanted to sit down, I can show you how to basically create a classical inheritance model in JavaScript. It's been done dozens of times because a lot of people who have gotten into the language also weren't comfortable when they came from Java. And they're like, oh, how do I work with this? Oh, it feels so weird. And so then basically what you do is you put a little layer on top that cripples JavaScript and gets rid of all of its really cool abilities. And then you give it to someone who's comfortable with Java and you say, there you go. Now you can go write your limited version of JavaScript stuff and feel comfortable. But it's actually ultimately more powerful. You'll hear some people sort of demean it like, oh, it's not very object-oriented, or it isn't really an object-oriented language. That's like fundamentally not true. It's just a different way to work with the relationship between objects than other programming languages. Let me see what else. It didn't have much else. Yeah, we'll talk about this in the next class, but you can also set a whole prototype object using the object.create method. And that gives you a lot of flexibility and capability to create sort of inheritance trees as well, just building on top of each other. Yes?
The notes that you saved today,
Those are, I did post a link
oh,
in Slack already, so those should be up on GitHub. I might need to update them because I did make some changes. But yeah, they should be up on the GitHub project for the class. You mean the ones for all of the code? I'll get those up right after class. Yeah, I'm gonna move them into like a folder, like an examples folder or something, so they're not just sitting right there, and then I'll just upload that. That'll be in like 5 minutes. Thanks for reminding me, otherwise I probably would have forgot. Any other questions? Yeah, sorry, it's later than normal. A little bit of chaos getting started.